In this video we will start optical instruments, very important topic of this chapter. Generally in this chapter we are going to discuss about two optical instruments, one is microscope and the other one is telescope. So microscope, what is the purpose of using a microscope? That is, it is an optical instrument which magnifies a small object. In fact, in biology lab you may have seen microscope, those are compound microscopes. So here we will discuss about two types of microscope. One is simple microscope and the other one is the compound microscope. And the important thing that we are going to derive from for microscope, that is magnifying power or magnification of a microscope. So we know that magnification or magnifying power means it is the ability of the microscope to magnify the image, okay, of an object. So this, it has a formula, magnifying power, sometimes we write it by capital M or small m. So this magnifying power, it is the ratio between visual angle formed by the final image to the visual angle formed by the object kept at D. Okay, before we understand this formula, let us think a practical case. Suppose instead of using without using any device, any microscope, telescope, anything, in naked eyes, if you look at any object, when the object is far away from your eyes, then the size of the object remains small, right? But as, suppose this is your eye position, just a second, suppose this one, eye position, and some object is there, this one is the object, okay. Now when the object is far away, the size of the object will remain small. As the object comes towards the eyes, at a particular place the object gets the maximum size, or we can clearly see the object. Suppose at this position we are able to see the objects clearly, and this position is called distance, least distance of distinct vision. In class 10 you got this one, least distance of distinct vision. For normal human eye, this least distance of distinct vision is this much distance at which the clear image of the or the clear view of the object can be taken. That distance is, for human eye, for normal human eye, it is 25 centimeter. Okay, so here this capital D means least distance of distinct vision, which is 25 centimeter. This is with naked eyes. We are not using any this one microscope. We are not using, just it in naked eyes. This is the least distance of distinct vision. So in this equation or in this formula, first what we have written, visual angle formed by the final image by visual angle formed by the object when the object is at D. So here is the object which is at D. Now this object, how much angle the object is forming at I? This angle is how much? Suppose theta. So this theta is this one, visual angle formed by the object when the object is at D, at least distance of distinct vision. Okay, now this part, visual angle formed by the final image. So suppose this is the actual position of the object when the object is at D. Now you have used the microscope you are using now, and after using the microscope you got the image somewhere here. This is the image this time. Okay, so this image, this is the final image, suppose. Okay, so this image, how much angle it is making at your eyes? This angle. So this is this part, visual angle formed by the final image. Okay, this much angle. So generally this angle we denote it by beta, and the previous angle, that means the angle formed by the object when the object is at D, is given by alpha. So the ratio between alpha and beta, or beta and alpha, that gives us magnifying power or magnification. Then simple microscope. Simple microscope is nothing but, it is a simple convex lens. As we know that in simple convex lens, when the object is kept between focus and optical center, it gives us an erect magnified virtual image. So if this condition gives us an erect and magnified image, this a simple convex lens can be used as a microscope, right? So simple one. So see the diagram, this is the lens, then object AB, light ray is going this way and this object is placed between the optical center and focus. Focus will be somewhere here maybe. Okay. Now one light ray goes parallel to principal axis. After refraction it should go through the focus. This is one light ray. Another one which is passing directly through optical center, there will be no refraction, directly it will pass. Both these light ray, if you extend in backward direction, they are meeting at this point, and thus this is the virtual image of the object AB. Fine. This is our eye position. Now we are here to find out magnifying power, and as I told you, magnifying power is a ratio between beta and alpha. So in this figure, which one is beta and which one is alpha? See, alpha means, just now I told you that this is the angle made by the object when the object is kept at least distance of distinct vision without the magnifying glass or without the microscope, in naked eyes, right? So if it is in naked eyes, here this condition is not shown. You have to just imagine that if the object is at least distance of distinct vision, how much angle it will make in our eyes, that is alpha. Okay, we are going to discuss about it later on. Now beta means it is a visual angle formed by the image. So where is the image? Final image is this one. So this final image, suppose if this is the eye, we are generally taking the light, this okay, angle formed by this light ray with the horizontal line or with the principal axis. Suppose this light ray is directly going to our eyes. Okay, so this light, it is making how much angle with this base? This angle, and this angle is nothing but beta, as shown in the figure, this one, beta. Okay, then from the figure, for small angles we know these conditions, we have applied many times. Beta is nearly equal to 10 beta, and if it is so, 10 means it is perpendicular by base. So if beta is this angle, where is the perpendicular? We can take the perpendicular as this one, AB. Where is the base? Then base will be this part. Okay, so that's why I have written here, this is nothing but height of the object, which is given by h naught. Okay, so perpendicular by base, base is this part, OB. So this OB is nothing but UE. U means generally object distance from the lens. So since this is the object, this is the object distance, UE I have written. E for, actually it is for eyepiece, but in this particular case, though eyepiece and objectives are not separated, anyways you can give the name only as U, or you can give UE, so that in next case when we will discuss about compound microscope, you will not have confusion. So that is why I have written UE here, this one. Okay, so this is perpendicular h naught by base UE. So this is for beta. Next, alpha. As I already told you that when you are thinking about alpha, we are not going to think about the instrument, it is with the naked eyes. So suppose if this is eye, this is your eye position. Okay, suppose I am drawing it here. This is eye position, suppose. Okay, just imagine it is human eye and the object is kept at least distance of distinct vision, suppose somewhere here. Okay, so what is this distance from human eye to the object? This base side, least distance of distinct vision, D, and the height of the object is how much? H naught. So this angle is alpha. How much it will be? Alpha means it is nothing but 10 alpha. So 10 alpha means perpendicular by base. Perpendicular is h naught, base is D. So I have written here, it is h naught. It is h naught by D. Now if you take the ratio for m, beta by alpha means 10 beta by 10 alpha, h naught gets cancelled, we get D by U. This is the general formula, but there are some special cases. General formula is D by U. Now let us see. Okay, case 1, special case. For maximum magnification, as already I told you that an object remains magnified, uh, or the maximum magnification occurs when the object is at least distance of distinct vision. So that is why for maximum magnification the image should also be formed at the least distance of distinct vision, because in that case only, suppose when the object remains so very it is far from our eyes, so the shape of the object or the size of the object remains very diminished, but as you bring the object and when the object reaches at D, it becomes magnified. So for maximum magnification V should be equal to minus D. Why minus? Because see in the figure all the distances generally we are taking in which side? In left hand side. So in left hand side the distances are generally minus if you use the sign convention. Okay, so that is why V should be minus D. U is minus UE. U is, it will remain same, just putting the sign convention it becomes negative. Now this is the lens formula which can be which we can apply for the simple microscope also. There is it is nothing but a lens only. So 1 by f equals to, in place of V minus D, in place of U minus UE. So minus UE and minus is already there, it will become plus, and this thing we get this formula, right? That means 1 by U means this value. So in the previous formula, in the general formula, we can substitute 1 by U. What was the general formula? M equals to D by U. So D by U means D into 1 by U, and 1 by U means this value.